Burton Elementary Number Theory, Chapter 1, Section 1, Problem 1b. We're going to establish this formula by mathematical induction for all n greater than or equal to 1. So let's jump into this. We need to know what induction is. So here's our definition of induction. If you're having a trouble getting a feel for this, look at our previous video for Part A. But again, if we're trying to prove something's true for all positive integers, right? So here we're trying to prove this equation is true for all positive integers. Then all we need to do is show it's true for the number 1, and then that's called the base case. And then the successor condition, which is our second part, is whenever it's true for k, it's true for k plus 1. So you can think of this as, well, we know it's true for 1, so then if k equals 1, then it's true for 2. And then if k equals 2, then it's true for 3, and you just keep following for infinity, and it's true for every number. So let's jump into it. Whenever we're doing induction, remember the base case should be the smallest value that we're interested in. So here are the values n equals 1, so we're going to start base case n equals 1. If this equation doesn't hold for n equals 1, then we're done. This is an invalid equation. So we plug in 1. The left-hand side is the sum of all odd integers up to 2n minus 1. So there's only one integer involved, and then the right-hand side is 1 squared. So this is the base case. Typically we say the base case is the easy part. Now we need to set up the hard part. Remember, the base case is what we did. It's this first step here for the theorem. So let's look at the successor condition, or the inductive step. So this is our second criteria to be able to apply the theorem. What do we want to do? Just read the theorem. We want to assume the equation holds. Remember, we're trying to prove that our set S is the numbers, positive integers, for which this equation holds. So we assume the equation holds for n equals k. And now we want to show that it holds for the next value, which is k plus 1. So for our assume equation, all we're doing is taking what we were asked to prove and plugging in k. It's the same exact thing. And then the show equation, we're just taking assume and we're changing k to k plus 1. So for our show equation, instead of going up to 2k minus 1 on the left side, we're going to replace k with k plus 1. So literally replace k with k plus 1. And then on the right side, the same thing. We're going to replace k with k plus 1. Now again, the next step, there's no clear way forward. Okay, so there's no prescription on how to do this. This is something that you need to do some examples and kind of get a feel for it. So in part A, we started with the assume line and we manipulated into the show line. Here, a better technique is to start with the show line and then reduce it to something that we know is true. Some hints on how to get this done. You know, when you do proofs by induction, you're always going to have to use this equality, right? You have to use what you're assuming to show the show line. So how we do this is, here's our show line. So I wrote that up top. That's our first line. And then we're going to manipulate this in a way that we can take advantage of the assume line here. And you can see how we do that here. So we just get a k squared on the right-hand side, which we know is equal to, this k squared is equal to our expression. That is where we use the assume line, or those red characters there. And then obviously we can cancel out a bunch of terms on both sides. And finally, we reduce this to something that is a 2k plus 1 equals 2k plus 1 for all k. Therefore, we know that the show line is correct. And what that means is we showed the base case, which was this first step, and then we showed the successor case, or the inductive step, in our second step, which now means that the set of all positive integers is S, or in our case, all integers solve this equation. Thanks for watching. Hope you've enjoyed the video. Make sure to subscribe so you don't miss out on future videos. And if you have questions, make sure to ask them in the chat.